Hi everyone. There is no doubt that 2024 is the year of AI or artificial intelligence. There are a great deal of applications that are expected to be happen because of AI or artificial intelligence. For example, in chemistry and physics, it's expected from AI to smooth out the complexity in the computations, but also to simplify them and make complicated physics and chemistry simulations more accessible. But now, what about quantum computing? Did AI outperform quantum computing already and we are no longer in need for it? Are we going to have a real cold quantum winter? Which one to bet on? AI or quantum computing in 2025, 2026, or even in 2030? Well, it might be surprisingly wrong to compare quantum computing to AI. Why? We are going to discuss this in this video. This is Taha Salim. I'm co-founder of MolKet. It is a startup that is based in Amsterdam Startup Village. And in MolKet, we offer consulting services and software services that combine AI with high-performance computing, HPC, and quantum computing to perform quantum molecular dynamics simulations and quantum molecular-based cryptography. Now we are seeing the great capabilities of AI. Recently, like a few days ago, Sam Altman and OpenAI announced the new AI package called Sora. And this is a fascinating package that can generate videos based on text prompt. So you can enter what you describe in the video and it can generate for you video up to 1 minute. For example, in this scene, the AI generated a complete video based on a text that describes a woman that's walking at night in Tokyo and has some lights in the streets. And it generates all of this complexity of characters and lighting and the streets. Of course, there is some defaults that are lying around. But imagine this huge leap that happens this year comparing to the previous year, 2 years before, 3 years before. It is expected to have exponential progress in the next few years for AI-based applications like video generations and text-based applications. Next to that, we have LLM-based applications like ChatGPT and Google Gemini, which have made significant leap of what we know from AI applications. You can just interact with a prompt, ask any questions, and the answer that you will have, it's actually concluded from vast millions of resources that are scattered around the internet. Those resources that the AI models have been exposed to and used in its training. And without too much time you used for search, you receive the answer that's well organized and tailored for you based on good algorithms that's used for reasoning. It's now widely used in many applications like in hiring process, in copy editing, in summarizing documents, and there is great deal of applications in writing codes, for example. So codes will no longer be like an intellectual property you develop. It just, the intellectual property will lie in the architecture and the algorithm, because this kind of AI-enabled engines can write the code for you. Maybe not perfectly now, but that's expected to happen in the next few years. It also provides great business value in automation and automating surfaces, and gradually we will see a reflection of AI automated surfaces in our daily life, perhaps this year, perhaps next year, and so on. So there is no doubt that 2024 is the year of AI. AI is not only LLMs or GPT-like applications or Sora applications that could be used to generate videos. AI is a big umbrella to several branches like machine learning, deep learning, natural language processing, computer vision, and GPT-like models. Now, how this would strike quantum computing with a real cold quantum winter. By quantum winter, I mean drying out investments, but also the market potential of the technology, the market demand that's composed of customers' need and what they envision for applications to be used from this technology. In the past few years, there was a great push for the limits of quantum computing. There is a large segment of the community believed that quantum computing would outperform any classical computer ever, basically in everything. It will perform matrix multiplications much faster. It can compete with CPU applications like matrix operations and matrix inversion and processing of information much faster than classical computers or conventional computers. But this is actually not correct. I wanted to say it in a clear way. There is not really a misinformation, but there is so ambiguous expectations from what quantum computing can offer and actually what it is meant for. Because the aim is not about projecting the classical thinking into quantum and basically duplicate everything we do on classical computer and do it on a quantum computer. This is not the aim of quantum computing. There is a great confusion about what AI can offer and what's expected to have from AI in this year and what's expected to have from it in the future, and the offerings that are expected from quantum computing. And also the readiness level of the technology. The readiness level of technology in AI is entirely different from the readiness level in quantum computing. Before going any further, I would like to define what quantum computing is meant for. And actually, quantum computing is an application of the language of quantum mechanics. The language of quantum mechanics allows us to do three main fundamental applications that they are really fascinating. First, it allows us to create quantum systems that leverage quantum properties like entanglement, superposition, and coherence to create quantum sensors. Quantum sensors are able to provide precision and accuracy much higher than the conventional classical sensors. And also it can provide and sensing quantities that are beyond the reach of classical sensors. The second application is in communication, that using this language, we can send the information and encrypt them over optical networks. And this is called quantum communication and cryptography. The third application is the computing part, that we can use and harness the powerful quantum properties like the entanglement, superposition, and the coherence to induced in systems to perform computations with them, to mimic the old Turing machines and perform operations with them. And this is fascinating by itself. However, it gives us an idea that not every operation we can do in a conventional computer on my laptop, we can do it in a quantum computer. So quantum computer excels in certain operations that require exploiting large probabilities and large possibilities in large space of configurations, for example, or possibilities. But it's not good to do matrix multiplications and multiply two numbers together as we can do in Python or any normal calculator, basically. And in quantum computing, basically, we mimic nature by nature. So we can compute things using atoms and molecules or integrated circuits that are arranged in a way that can create quantum properties, and we can perform computations with them. So now we know what quantum computing does. So the question is it fair to compare what quantum computing can do to the AI capabilities? That's based on what we have discussed so far. It is not fair, and maybe even the comparison is not valid. There is three main things I would like to mention. Time-wise, AI has been around for more than 40 years or maybe 50 years now. So it started and followed this wave of ups and downs where in 50s and late 50s, engineers were enthusiastic about the AI capabilities and the neural networks. And then we got the first AI quantum winter. And then late 70s, the excitement started to back again and market potential. And then we got into another winter and so on. So this wave of ups and downs was associated with AI. And like any kind of technology, it takes time to be mature and materialized in the market itself. In fact, AI took such huge leap after advancing the hardware, in particular that's related to graphical processing units and the ability to do things much faster than on conventional CPU related to matrix operations. And there is a nice example I wanted to mention. Actually, the huge leap that happened in ChatGPT like applications, it's actually took off in 2017, where a nice paper called Attention is All What You Need. That paper that's published in 2017, I will leave the link of this paper below. It's actually made a huge leap for the transformers and encoding decoding of information used in transformers to create these attention layers. So that's boosted the ability to do ChatGPT application. So imagine the timeline from 50s till 2017 till now, where we see a real value of AI that's started to be materialized around us and bring business value. Comparing to quantum is not at this stage yet. Still, there is exploration, the proof of concept use cases that are propagating around. So there is so much to do, and also there is so much to apply and to configure. So much to apply and figure out what we can do from quantum computing. And this brings to the second point, is the technology readiness level. AI is now more mature than quantum computing. So in fact, quantum computing, they are manipulating qubits, and the current ratio between logical qubits to physical qubits are still significantly high. To do certain molecular simulation on a quantum computer, you would require thousands and thousands of gates and having very lengthy quantum circuits with significant errors. So that's still really in early development so far. It cannot be really compared to materialized, mature AI backend surfaces. So we cannot compare quantum computing that is in TRL 2 or 3 to AI that's now started to be beyond 7 or 8, or perhaps in 9 at a later stage. So there is no valid comparison here. Hence, third point is about the offerings. AI offerings are different from quantum computing. In fact, quantum computing could be part of AI's offerings in the future. AI now is used to enhance and boost the kind of operations that we do. Like you can generate videos with it, text with it. It can generate exams. It can do so much of applications. But how about the physics applications? So AI could use quantum computing and quantum computing algorithms to learn about the physics and hidden layers of physics inside physical systems and become much better physics-informed AI engine. So it is really unfair to compare AI's offerings to quantum computing offerings, because what Richard Feynman, so he was the first one to envision doing computations with atoms and the molecules in order to calculate properties that of other atoms and the molecules as well. Having said that and having that in our mind, it is very hard to compare quantum computing offerings to AI offerings if this would make sense, because they are really play in different categories. With quantum computing, we try to project and represent the problem in a way that could be understandable by a quantum computer. So it can harness the power of quantum properties like entanglement, the superposition, and coherence. And with that, that's valuable and valid for to some extent for certain applications that are dominantly in for physics and the chemistry simulations. And it could be extended to machine learning in problems that's related to search for minima and computing derivatives, for example. So at the end, we are trying to compare quantum to AI, and they are playing in two different categories. So how they could be integrated together. So there are a lot of progress are being around to combine both, and the quantum could boost AI in developing algorithms in a much better way, for example, to harness the way that algorithms are developed and designed for quantum computing, and harness this way in training AI models, like what's called quantum-inspired algorithms. The second thing, quantum computing algorithms could help making AI better informed about the physics of quantum systems. So we can train AI models on a quantum computing backend to understand more about the physical properties of the backend itself, the quantum hardware that are used for computations. And hence, we can have a better AI model that has a better physics and better knowledge about the physics itself. And this is like physics-informed AI algorithms. And of course, there is a lot of plans from different companies to combine quantum computing with other computing units. So we can have HPC that's integrated with quantum computing units. So we can have GPUs, CPUs, and QPUs, along with TPUs, like dedicated chips, like TPUs, and so on. So when you run a simulation, based on the complexity of each step, the proper backend will be chosen. So if you make string manipulation, that will be convenient to be done on a classical CPU, on a CPU. If you do heavy matrix multiplications and matrix operations, that might be better on GPUs. And if you want to exploit optimization and computing ground state energies, that would be high likely to be done on a quantum computer, and so on. So you leverage the synergy of combining these different types of hardware together in one pot that could be accessed via the cloud. Having said that, are we going to have a quantum winter? So it depends on who is asking the question. If the person understands what quantum computing is meant for, then most likely there will not be a quantum winter for this particular person, because they know that the quantum computing is still early. There's a lot of development in the quantum hardware, and when significant applications or significant breakthrough will happen, it will boost quantum computing and make it significant and bring business value for certain applications like physics simulations, chemistry simulations, and encryption, and certain applications in machine learning, and perhaps in design and enhancing the AI model to make it better in understanding the physics. So we have a better physics-informed AI models. If this person is expecting to do everyday operation on a quantum computer and like have something that can work now, where they can press a button and compute certain numbers or multiply numbers, that is not the case. And at last, AI will be part of our everyday life. Companies and the industry and perhaps education will depend on it in the upcoming years. However, in quantum computing, this is still in development, and it needs some time to be matured. It could be a few years, it could be 10 years, or we can have a breakthrough in the next upcoming days, and we can have a quantum value for the kind of applications that we have discussed during the episode. I hope by this I have clarified the difference between AI offerings and the quantum computing offerings and why it is not fair to compare them. And we are basically comparing two different categories together, and how they could be connected together and harness the synergy between quantum computing and the AI in certain applications, and what's expected from quantum computing, the technology readiness level, and the maturity of the technology. So feel free, if you have any questions or any ideas, to share them below the video, or if you have some feedback, please write it down and we will discuss it in the next videos. Until then, see you.